Hi everyone, I hope you are doing well. So in today's video, I'm actually going to go through the 2017 Specialist Maths Exam 2 multiple choice paper. Like always guys, before I start this video, if you guys want private tutoring in specialist methods, physics or chemistry, you can always email me through this email. Guys, we also have an announcement to make. We have just launched our website, which will be in the link in the description, and what we are doing is we are selling notes, and these notes include, right now we have some physics notes. Hopefully in the future we could put some specialist methods and some chemistry notes. They are very comprehensive notes, guys. They are very useful and very detailed. We are also going to be putting some practice exam papers too. They're going to be very cheap, and these practice exams, we put them to make sure that they're the same level as VCAR exam papers. So if you guys want, to practice, you can always go and check them out. So let's smash through this video. Question 1. The implied domain of f of x to this is what? Okay, normally what we do to find the implied domain is we look at the inside. So 1 over x, and we know that in the inverse of cos, it must be between -1 to 1. And if we solve this, so imagine what we're saying is, imagine drawing the graph 1 over x, this over here. Imagine drawing that. 1 over x looks like this. We'll have some asymptotes at y equals 0 and x equals 0. And we're saying that when is this graph over here, 1 over x, between -1 to 1? So for example, if I drew the graph, so example 1, let's say this is y equals 1 here, and this point over here is y equals -1. So when is the kind of that skin color between those? Well, it's only between those in over here. Here, and it goes to infinity, also -infinity to this point. And what's those points? Well, these points both are 1. So if you look at this, if you sub in 1, this point over here is 1. And this point over here is -1. So what are the implied domain? Well, so our implied domain would be x is an element from -infinity, which is between them, to this point over here, which is -1 inclusive, because we have greater or equal signs. Then union 1 to infinity, from here all the way to infinity. So yeah, that's our implied domain. So choose C. You can easily do this using your CAS. For example, I just wanted to show you how to use, I just wanted to show you how to use it, how to do it by hand, but using your CAS, let's do that. So what I would just do is, if I want to find domain, I'm just going to write domain of the function 2 cos inverse 1 over x, comma x. And it gives me the answer right away. So yes, same answer. That's great. Move on to the next question. Question 2. The solutions to cos x is greater than 1 over cosecant x for x is an element from 0 to 2 pi and where also pi is excluded. So if pi is excluded, we should already know that this probably is an asymptote due to the fact that we are dealing with cosec. So let's just sketch this. So let's sketch this. So for our sketching, let's first cos x. And actually, let's restrict it from 0 to 2 pi. Actually, no, they're not equal signs, so we need to less x 2 pi. And also 0.25 cosecant x from 0 less or x less or 2 pi. And there we go. So let's move these and literally pretty much zoom in. Remember from the question, it did tell us that pi is excluded, meaning that it's probably an asymptote. Let's check if that is true. So if I was going to a relation and say x equals pi, it is an asymptote. As you can see, the cosecant graph approaches it but never touches it. So the question's telling us, when is cos greater than cosecant? So what we're saying is, when is the blue graph greater than the red graph? So we can see that the blue graph is greater than the red graph from here to here. Where else? Also from here, from pi to this point over here, can you see the blue graph is actually greater than that red graph? And also from this point over here to 2 pi. So let's find those points of intersections. So, I mean, just we need to solve cos x equals 0.25 cosecant of x, comma x, given that we're going from 0 to 2 pi. And we get these over here. So our solution should be pi over 12 to 5 pi over 12. That will be one of them. Also, pi to 3 pi over 12. That's also another one. And also 17 pi over 12 to 2 pi. So which one would does that one have? So let's write them again here. So what we said was from pi over 12 to 5 pi over 12 union also pi to 13 pi over 12 union 17 pi over 12 to 2 pi. That is our domain. Which one does that look like? It looks like E is your answer for this one. Nice. Question 3. The number of distinct roots of this equation, where C is an element of complex. So we are also including our complex solutions too, not just our real solutions. So we want to find the number of distinct roots. Easy. Just go on your calculator and just say C solve. Be careful, don't write solve because that is taking the real values, not the complex values. So you want to write C solve. Z to the power of 4 minus 1 z squared plus 3 I times z minus 2 equals 0. And we solve for z. How many solutions? 1, 2, 3, 4, 5. We get 5 solutions. So D is your answer. That's how many roots there are. Question 4. The solutions to z to the power of n equals this, where n is an element of all positive integers, are given by what? Nice and easy question. This is quite used in a lot of practice papers. So what you're going to do is first let's change this into polar form. So we got Zn. This will be root 2 cis pi on 4. Okay, but let's write it as 2.5 actually, just 2.5. I don't like that root in this question, so 2.5. And okay, we also add plus 2k pi here. When you're dealing with these kinds of questions, we're also going to add plus 2k pi, where k is an element of all integers, but we are only, So, okay. And so if we want to get rid of that, n, what we're going to do is we're going to multiply it 1 over n on it. So, for example, if they will cancel out. If I'm doing that, what's going to happen? I also have to multiply by 1 over n, which will give me 1 over 2n cis. But what happens to the angle? The angle gets actually divided by that value of n. So imagine what's pi over 4 divided by n? It's actually pi over 4n. And also, what's 2k pi? 2k pi, divided by n, it is this, where also k is an element of all integers. So which one does that look like? Looks like E is your answer for that one. Remember, this one looks very similar, but the problem is it's saying k is an element of all reals. That's false. We can only take k as integers. So here. Question 5. On an Argand diagram, a point that lies on the path defined by this is what? I mean, there's many ways you can do this, but I think the most simplest way is to really look at this. Have a look at this. This is in terms of complex. So if I know this point, what I'm going to do is I'm going to write it in terms of complex numbers. So for example, I would write this point as z equals, so this will be 3. So it'll be 3 minus half I, because this is in terms of y, so we write it minus half y. And if I sub it into these using my calculator, if it says true, it means that is that value actually lies on that path. So let's try that. So what I'm going to do is, so I'm going to say the absolute value of z minus 2 plus I, so I'm just going to try the first one, is equal to the absolute value of z minus 4. Given that we're saying that z is actually equal to 3 minus 0.5i, half I, and we press enter, aha, true, so that is your answer. But we want to make sure if that's true. So let's try the next part at least. It should say false for the next one. So if that's a negative here, false. So yeah, the question 5A is your answer for that one. You can actually graph it and do the long process and see if that point lies, for example, but it's not worth doing all that work. So yeah, just kind of do this. Question 6. Given that dy dx ex arctan, the value of d squared y at this point is what? Okay, so I'm just going to ddx both sides. So d dx dy dx squared. It means I have to ddx the other side too. So e to the x. I'm going to write a tan inverse, much easier to deal with. Okay, this will become just d squared dy dx squared. And so here we're just going to use the product rule. So e to the x will stay. What is the derivative of tan inverse? It will be 1 over y squared plus 1. Because we derived it in terms of y, we have to multiply by dy dx. Plus tan inverse. What's the derivative of e to the x? It's just e to the x. Perfect. So this is d squared yx. But we also have this dy dx. So remember, but dy dx is this. So let's put that in there also. So hence your d squared dy dx squared is e to the x. Actually, let me write it nicely here. E to the x y squared plus 1. Dy dx is ex tan inverse of y plus tan inverse of y e to the x. So this point, and yeah, let's put on our calculator and sub in the 0.01. So what we just said was e to the x, so y squared plus 1 times e to the x times tangent inverse of y plus tangent inverse of y times e to the x. Have we written everything perfectly? Looks good. So let's sub in x is actually equal to 0 and y is equal to 1. And our answer is 3 pi on 8, which looks like B is your answer for that one. Let's go to the next one. Question 7. With a suitable substitution from this can be expressed as this. So we're going to have to use u substitution because everything is in terms of u. So I'm going to let u, in this case, be what's inside the square root, 2 minus x. So then dx is just 1 over the derivative of the function, which is just negative 1, du, which is just dx is hence negative du. Okay. So let's rewrite this whole function. So it'll be the integral. Well, this point 1, if I sub in 1 over here, so what's 2 minus 1? 1. And if I sub in 2, it'll be 0. These are your values here. X squared, because square root of, and we know 2 minus x is u, so we write it as u, times your dx, which is negative du. So we can put that here. Negative du. That's it. But we still have this x squared. Well, guess what? If you look over here, what about if we rearrange it to get x? So example, x is just 2 minus u. So imagine subbing that into the function. So negative 1, 0, 2 minus u squared u to the power of half, which is the square root of u, du. And let's kind of simplify this. So 1, 0. This will be, if I'm, it'll be 4 minus 4u plus u squared, u to the power of half and du. So simplifying that, expanding it, so it'll be 4u to the power of half minus 4u to the power of 3 on 2 plus u to the power of 5 on 2 du. So which one does that look like? Looks like D is the answer for that one. Is that right? Yep, that looks good. So that's that. Nice and easy. That was not too bad. Ooh, let me just move this over here. Next question. Question 8 says that let f of x be this, where m and x are elements of all roots. The gradient of f of x will be strictly increasing. So the gradient, which is f dash of x, so let's find f dash of x, which is just 3x squared minus 2mx, pretty much. Is that right? Yes, and if we want the gradient to be strictly increasing, we want f dash of x to be greater or equal to 0. We want it to be strictly increasing. So what we're saying is 3x squared minus 2mx must be greater or equal to 0. So if I take a common factor of x out, it's pretty much a quadratic. So if I drew this quadratic, we have two cases actually here. Let's say the case is that m is greater than 0. M is greater than 0. So our graph will look like, so it will pass through 0 because x equals 0, and if it's greater than 0, we'll have a positive, we'll have s to be over m here, which will be, so if I was nicely drawing this, it's a positive parabola, this would be 0, this will be 2m over 3. So when's it strictly increasing? Well, it's strictly increasing from here, the midpoint, all the way up. So what's that midpoint? That midpoint is the midpoint of both of these. So if I add both of them, so 0 plus 2m over 3 and divide them by 2, it will give me m over 3. So pretty much x is greater or equal to m over 3. That will give us where the gradient is positive. But that's the case when m is greater than 0. I need to double check if that's also true. Let's take the case that we say m is less than 2. So let's take the next case, which we're saying m is less than 0, so a negative number. What happens? Well, the graph, again, will still pass through 0. So it will still pass through 0. But it will have over here, which will be, again, 2m over 3. So if that's, yeah, and if I just drew this like that, well, that's not a nice drawing, but like this, the midpoint over here will again be m over 3, and when it's strictly increasing, it's also strictly increasing from that to be greater than, so x must be greater than m over 3. That's 100% true, so that's great. So which one would that be? So m is greater than m over 3. Looks like B is your answer for that one. Choose B. Nice. Question 9. Consider dy dx to be this, where y1 equals y0 equals 2. Using Euler's method with a step size of 0.1, an approximation of this, which is y2, is given by what? Okay, not too bad. So we are going backwards. For example, our x0 in this case is 1, and our y0 is actually 2 in this case. We want to get where x2 is 0.8. So x1 would be 0.9. Imagine, because the step size is 0.1, imagine we're going 0.1 less every time. So what's our step size? Actually, our step size is going to be negative 0.1. Which makes sense. Like, imagine we're trying to find x1. It's just going to be x0 plus your step size, which our x0 is 1, minus 0.1, which is 0.9, which is true. So our step size is actually negative, which they haven't said here. So yeah. So just be careful. So step size is negative 0.1. So if our step size is negative 0.1, what's y1? Y1 is going to be y0 plus h plus, it's actually this over here subbed in, so f dash subbed in the value x naught. So let's do that. So y1 is y naught, which is 2 in this case, plus, which is actually negative 0.1. And imagine subbing x naught, which in this case is 1, so into the function, so 2 plus 1 plus 1. So y1 would be what? Let's check that. 2 minus 0.1, pretty much 4. That gives us 1.6. So that's 1.6. So y2 is just y1 pretty much plus, let's write it. So y1, which is 1.6, minus 0.1, which is just step size. And now subbing the value x1, it will be 2 0.9 squared plus 0.9, which will just be 1.9, putting all together. So writing this, so we get this over here, minus 0.1, 2, 0.9 squared, plus 1.9. Enter that, and control enter, and we get 1.248. That's your y2, so that's your answer. So choose B as your answer for that one. Question 10. A function f its derivative f dash and its second derivative f double dash are defined by this, with the following properties. So f of a is 1, f negative a is negative 1, f of b is that, and f double dash is given by this. Find the coordinate of any points of inflection of the absolute value of f dash of x. Okay, so what I would do is actually start visualizing it. So if I just draw a graph for this question, for these kind of questions, it's much better if you kind of draw a graph and see what that pulls out to be. So for example, let's say A is a point, this A. Let's say it's point A here. So it means that negative A would be here. So f of A is 1, so it means a positive 1. So put it here. F negative A is negative 1, meaning that it's over here. Okay, and let's say that B is right over here, and this hence is negative B. And we know that f of B is negative 1, so it goes right over here. And f of negative B is 1 over here. So that's good. And let's look at the f double dash, the double derivative. What do we know about the double derivative? If we let it equal to 0, what do we know? We actually solve the points at, there's a point of inflection. For example, if I let f double dash equals 0, we get x equals b. This becomes 0 anyway. And x equals minus a. Alright, so imagine there's a point of inflection. So we know that the point of inflection at x equals b. So here are the b values. So imagine that it goes like this, nicely touches it like this, and goes up. Okay. And there's also a point of inflection at negative a. So if it's like this, goes like this, but the problem is it's not passing through this point. Wow. Wait, what about if we do, so what about if I do this? Nope, that doesn't work. So it has to go like this for B, passes through this, and if I do this, it goes downwards. So looks like A does not have a point of inflection. Sorry guys, it's actually being squared. Remember, like, let me explain what I mean. So imagine f of x equals x to the power of 3. Now x to the power of 3 we know has a point of inflection at 0, don't we? Just let me explain what I mean. So imagine this is here, and we have a point of inflection at 0. So imagine double deriving it. So f dash of x is just 3x squared. F double dash of x is 6x. And imagine, letting it equal 0 and we get x equals 0, which makes sense. But this is what we actually need to understand about f double dash, like the double derivative. The sign needs to change. For example, we know that this point here is 0. If you sub in 0 here, it's actually f double dash is 0. But what about if I subbed in 1? If I subbed in 1, it will be positive 6. And that's good because it is going positive. What about if I subbed in negative 1? Which is over this point over here. It actually gives me negative 6. Look at the difference. The sign changes. Here it's positive and here is negative. At that point where it's 0, those are supposed to be changing. So if I look over here and everything's being squared. For example, if I put negative 2, negative 3, negative 4, it's always going to be positive and there's no change of sign. So if there's no change in sign, we know that this is always going to be greater than 0. If we know it's greater than 0, let me tell you, if we know that f double dash of x is equal to 0, what do we know? It's a point of inflection. But if f double dash of x is greater than 0, we know that's a minimum point. If f double dash is less than 0, it's a maximum point. So for this example, if it's being always squared, it has to be a minimum point. So that's why when we're drawing this graph, it's going to be a minimum point at that point, not a point of inflection. And it nicely passes through that point B. So this is how the actual graph looks like. And if we're taking the absolute value of that graph, what that does is whatever is at the bottom, it gets reflected along the x-axis. For the example, if I take this is all on top, this is at the bottom, so it's going to be reflected like this. This is at the bottom, so it's going to be reflected pretty much. And yeah, that is your graph of f double dash. So f absolute value of f of x like this. So, all right, that's good. So what is the only point of inflection? The only point of inflection is actually over here, which is, what's the coordinate? It's b. And remember, this over here is 1 from these ones over here, so b1. And yeah, that's your answer. So it can only be E. All right, hope that was easy to understand. Question 11. The vectors A and B and C, where D is a real constant, are linearly dependent if what? So look, you can do the long method by solving it, especially you can use your CAS in this test. So I'll show you a quick way. For example, let's say we had vectors A, vector B, vector C, and they are linearly dependent. If I put those vectors using the determinant, this function, right, determinant, I'm putting in a matrices, where here is I, this is J, this is K for A. So for A, B would be I, J, K for B. For C, it would be I, J, K for, C. And if that determinant actually is equal to 0, guess what that means? It is linearly dependent if it's equal to 0. But for this, what we want is what value of D will give us that linear dependence. So why don't we just use our CAS and use the determinant to find those? For example, let's do that. So if I just go here and write determinant of, go in here and pull this matrices out. And so this is A over here, so it'll be 1. So actually A is just 2, 3, D. 1, 1, -4 for B. For C, it's 2, 1, -2. And we want that determinant to be equal to 0. That means that they are linearly dependent. So equal 0. And press enter, and we get this. And we can just solve for D now. D is equal to -14. So that is when linear dependence actually occurs. So choose C as your answer for that one. Question 12. Let R of t, this, where t is greater than 0, where A and B are elements of all reals, let be the path of a particle moving in a Cartesian plane. The path of a particle will always be a circle if what? So, okay, let's make this into a Cartesian equation to make it very visually look at it. So, by using this property, cos squared of x plus sine squared of x is actually equal to 1. So, here, this part here will be x is equal to 1 minus root a sine t, and the other one will be y equals 1 minus 1 over b cos t. And we want to solve for sine t here, so it will be root a 1, so root a sine t 1 minus x, hence sine t is 1 minus x over root a. And imagine squaring sine t. So squared will give us, well, it's actually very, will give us what? 1 minus x squared over a. Let's do that for y. So for y, again, we needed to get cos, so it would be 1 over b, 1 minus y, 1 over b cos t, 1 minus y. Multiply both sides by b, we get cos t, b, 1 minus y. And imagine squaring cos squared t. We get b squared, 1 minus y squared. Okay, So we got those properties, and let me just rub this, all of these now, pretty much, and put these all together. So using this property over here, where cos, we know that this plus this is equal to 1. So let's put those in. We know that sine t, in this case, is just 1 minus x squared over, in this case it's a, is plus b squared 1 minus y squared equals 1. Okay, now this is an equation of a circle. Now what values of a and b? Okay, let's have a look at this. So, I mean, let's write this nicely. Like, imagine taking a negative out. We can rewrite that as just x minus 1 squared over a. Also this one as, you know, y minus 1 squared equals 1. So look at this. Let's think about it. If these values of a are a problem to us, because if we want it to be a circle, actually, I want to, like, we don't want anything to be divided by these. If it's divided, it kind of dilates them and makes them an ellipse. But if we want a circle itself, what do we need to have? Well, let's get rid of the a by multiplying everything by a. So, for example, if I multiply every side by a, that gets rid of that. It'll be ab squared, y minus 1 squared, and this will be a. Okay. Have a look at this. That's good. This is great. This is 1. It's been divided by 1. That's great. We also want this to be like by itself as 1. So how do we get that? And a is great. A is just greater than 0. It's the question tells us that a and b are elements all real. So that's good. That's our radius. But this is where we want this whole expression. So this whole expression is divided by 1. That's great. What about this whole expression? If we want it to be divided by 1, like if we want the bottom to be 1, we need to have this expression over here to be equal to 1. So if ab squared is equal to 1, guess what happens? We can rub this out. And if that was equal to 1, guess? It's an actual perfect circle where both the bottoms are actually divided by 1. See? That's only if ab squared is actually equal to 1. Which actually gives us a as our answer. Nice. Question 13. Given the vectors a, b, are these, the vector resolute of a in the direction of b is what? Very typical question, very easy. Just use your cats. So the vector resolute is just a dot b, the magnitude of b squared dot b, where it's in the direction of b. Just using this notation, let's just do it in our cats. So I'm going to define the vector a as 3, negative 4, 12. B is a vector 2, 2, negative 1. And so it's being divided, and go on menu, go on matrices, and go to the dot product. We want to find the dot product of a and b. We also want to find the magnitude squared, so norm of b squared times b, the vector b. Enter that and we get this. That's your answer. So the one that looks like that is actually C. So choose C. Wait, yep, is that right? So negative 28, 9, that's good. Good. Yes, that's good. Next question. Question 14. Two particles of mass m1 kilograms and m2 kilograms are connected by a taut light string that passes over a smooth pulley. The particles sit on a smooth inclined plane as shown in the diagram. If the system is in equilibrium, then m1 over m2 is equal to what? If the system is in equilibrium, the acceleration is 0. So to break this down, to find m1 over 2, what I'm going to do is, I'm just going to say, for example, what is the direction of acceleration? As an example, let's say acceleration goes like this, but acceleration is 0 in this case. But for example, if acceleration, let's say in a way, if m2 is goes down, this one will go up. So what does that tell us? That I'm going to take this way as positive, and I'll take this way as positive. So that's good to know. Equilibrium means acceleration 0. So we know that, if I break this down into its components, and that's going to be m2g. That's m2g. So this will go like this, because this is going down, so this will go down like this. So we're going to look at this over here, And because we're taking that as positive, we're also going to have actually tension that is occurring on the string that are the same value because they're occurring at the same rope. So for this one over here, because we're taking this way as positive, it's going to be M2G sine theta, where this is your theta over here. Okay, minus T, this tension over here that's occurring over here, should equal mass times acceleration, but our acceleration is 0, so we let it actually equal 0. So that's good. Now let's do the same for this one over here. So if we break it down, okay, if we break it down, and that's M1G, so breaking this down, we get down, left. So because we're taking, this way as positive, so it will be tension minus M1G sine 2 theta. And that should also equal 0, because it's in equilibrium, 2 theta over here. Okay, that's it. We have enough expression to kind of deal with the question. So I'm going to delete this and let's have a look at this. If I add both of these equations, we actually get rid of that t. So that's actually good if we add them. So let's add them. So it'll be M1, so actually it'll be M2G sine theta minus M1G sine 2 theta must all equal to 0. So M2G sine theta is actually equal to M1G sine 2 theta. Now that g's can cancel out. There's no need for those g's. That's good. We can also simplify that 2 theta using our double angle formula. So M1. So what's sine 2 theta? It's actually just equal to, so 2M1, it's equal to sine theta cos theta. And we've already put a 2 here, so yeah. Now we can cancel those sine thetas over here. We get M2 is just equal to 2M1 cos theta. We want M1 over M2. So if I, for example, write it nicely, so like M1's here, multiplied by 2 cos theta. If I would bring that 2 cos, if I divide both sides by 2 cos theta, we get M2 times 1 over 2 cos theta is equal to M1. And we divide both sides now by M2, so we get 1 over 2 cos theta is equal to M1 over M2. So that is the one that we want. So it's actually this expression, which can be written as, if we bring that cos on top, it's just going to be cosecant of theta divided by 2. That was very long. Cosecant theta divided by 2. Wait, is it, what am I doing? Wait. No, cosecant is 1 over sine. No. That's why I'm just looking at the answer. It's not there. So it'll be, so it'll be secant, actually. So 1 over, so remember guys, 1 over cos is actually secant. 1 over cos x is actually equal to secant x. Wow, I accidentally thought it was cosecant, but it's actually, yeah. So cosecant x. So in this case, it would be secant theta over 2, pretty much. That would be the only possible one that looks similar to all of them. Because all of them had secant, and I was like, what? So only A would be your answer for that one. That's that. Make this smaller. Okay. Question 15. Let's have a look at this. A body has a displacement of 3I plus j meters at a particular time. The body moves with a constant velocity, and 2 seconds later, it's displaced at this. The velocity in meters per second of the body is what? Okay, think about it like this. So imagine it starts over here, and the displacement over here at this point is, remember, displacement is just the position. So 3I plus j. And for some you know, what's it, how many seconds? 2 seconds later, he's actually over here, which the displacement is, let's say, negative I plus 5j, as it's in the question. And it takes him 2 seconds to move that distance over here. So we just need to find what's that distance. Remember, velocity, what is the definition of velocity? Velocity is just displacement over time. Displacement over time. So what is that displacement? What is that change in position? It's just this minus this. That's going to give us our displacement. It's just negative I plus 5j minus 3i minus j, which will give us negative 4i plus 4j. That's your displacement. And imagine dividing it by the time. So velocity is just negative 4i plus 4j divided by the time, which is in terms of 2 seconds. That will give us negative 2i plus 2j, which gives us B as your answer. Nice. Next question. An object of mass 20 kilograms, initially at rest, is pulled along a rough horizontal surface by a force of 80 newtons acting at an angle of 40 degrees upwards from the horizontal. A frictional force of 20 newtons opposes the motion. After the pulling force has acted for 5 seconds, the magnitude of the momentum in kilogram meters per second of the object is closest to what? So let's just draw a nice, to really have a look at this. Imagine we have a mass. This mass is over here, and it's being pulled, it's actually being pulled by a force of, 80 newtons at an angle that is 40 degrees from the horizontal. There's also some frictional force that's occurring. So imagine there's also another force that's occurring, and that's your friction force. Let me just draw it over here nicely. This friction force is opposing that motion when it's 20 newtons. And so we want to find the momentum. And remember momentum, what's the formula for momentum? Momentum is just m times v. So we already have the mass. We just need that velocity. Okay, what do we have? What information do we have to get velocity? Well, we know it starts at rest, so u is equal to 0. We know the time it takes to go there is 5 seconds. We want to calculate the velocity, and we can actually get the acceleration too by, looking at the formula. F net is equal to mass times acceleration, the acceleration. So we just need to find the net force. Well, the net force for this one over here is what? Well, have a look at over here. If I broke this down, if I take this force over here, this force, because that's the one that's causing this acceleration, so this force minus this force, it will give us the net force. So what's this force over here? It's just going to be AT cos theta, which is 40 degrees, minus 20. And this is your F net. So, and imagine, so then your acceleration is just the whole expression divided by the mass. And that should give me the acceleration. Let's do that. Now calculator. So we're just saying AT cos 40 degrees minus 20 over 20. That gives me 2.06, that. So that's acceleration. Now, coming back, so we got that as our acceleration. 2.06 meters per second squared. Now, we've got enough information to use SUVAT now. Now, the formula that I'll use for SUVAT here is going to be V equals U plus AT. And we're calculating velocity, so U is 0. It's just acceleration times time. Yeah, so it's just AT. So what's the acceleration? Our acceleration in this case is 2.06. The time it takes is 5 seconds. And that's going to give us a velocity, so let's do that. This times 5 gives us our velocity now. Now we have our velocity. We just need to multiply that by the mass, and that's going to give us our momentum. That's 206. So our momentum is 206. The one that's closest is D. So choose D as your answer. Nice. Question 17. Forces of 10 newtons and 8 newtons to act on a body is shown. The resultant force acting on the body will, correct to one decimal place, have the magnitude and acts at what degrees to the 10 Newton force. So, if that's 60 degrees from those, what about if I just take this over here, that 8 Newton force, and just kind of make it very parallel to, so make it parallel to the 8 Newton and say that's the 8 Newton force here. Imagine just adding them together. Imagine taking this force over here, taking the whole expression and just shoving it right over here by addition of vectors. Yeah, we can do that. So if we do that, what do we get? Let's do that again, actually. So we take this over here and put it over here. And that's the 8 Newton force here. Because we know it's a straight line, this has to be over here 120 degrees. And so the vector result would be this over here, this vector over here. That is your resultant vector. Now, how do we get that resultant vector, the magnitude of it? Well, okay, if we have the angle of that thing that we want to find, we also have these two over here, these two sides of the angle, we're going to use the cosine rule. The cosine rule is actually in your formula sheet if you guys don't know it. So it's written as this. C squared is equal to A squared plus B squared minus 2AB cos C. And for example, C is what we're trying to find, that magnitude. So it's just going to be C is equal to the square root. And in this case, let's call this A and this is B. So what's A? Well, we're saying 10 squared, so it will be 100. So 100. What's B squared? It's just 64. Minus 2. What's A times B? What's 10 times 8? Which is 80. Cos the angle that, for example, if this is C, the angle to it is 120. So 120 degrees, which gives us C is equal to what? Let's use our calculator. So C is just, so we can say 164 minus 280 times cos 120 degrees. Writing that gives me the answer 15.62. So that's the magnitude. So this magnitude here is 15.62, which looks like we can take D as wrong and B as wrong. And we also need to find the angle. So we need to find the act to the 10 Newton force. So, okay, this is the 10 Newton force. And what's the angle that acts with the resultant? It's this angle. Remember, this is the resultant, and this is the angle of 10 newtons. So that is the angle that we want. That's the theta. So we can also still use the cosine rule here, actually. So again, just imagine applying the cosine rule again to find this theta. We know that the opposite over here is just 8. So using the whole rule again. So imagine we know now C. So rubbing everything out. So imagine this is C, in this case. This is C. And and this is, let's say this is A. And this is B. Let's find it. So if I want to find the angle, so what's C squared? So C squared is 64 is equal to A squared, which is 50.62 squared, plus B, which is 10 newton, so 10 squared. So imagine that'll be 100. Minus 2, what's A times B? 15.62. You know, imagine like continuing on. B, which is 10. Cos, let's call it C, that value over here, that theta. Let me just call it actually theta. So let's use our calculator. So we're saying 64 equals this over here, this expression, squared, plus 100 minus 2, this expression again, times 10 times cos theta. We'll call theta as O in this case, and we get this expression. So if we solve answer comma O, given that the theta is between 0 to pi over 2 in this case, we get this angle over here, but that's in radians, so we need to multiply by 180 over pi. and that gives us 26.3 degrees. Well, it looks like A is our answer for this one. Nice and easy. 26 point. That is quite hard. It's a lot of, for a question multiple choice, all this working out, it's very long. Question 18. U and V are independent normal distributed random variables where U has a mean of this and a variance of this, and V has a mean of this and a variance of this. The random variable W is defined by 4U minus 3V. In terms of the standard normal variable Z, the problem with that W is greater than 5 is equivalent to what? Okay, so first let's find the mean of W. That's going to be the mean of 4U minus 3V. And using your, if you look at your formula sheet, this is how you, pretty much simplify. You take the constant out and leave that U in there. Take the constant out in terms of V. This is all in your formula sheet if you don't know how to simplify expected value kind of stuff. And so, what's the expected value of U? We know the expected value of U is 5 minus 3. What's the expected value of V? It's 8, which gives us like pretty much 20, 8 second 24 minus 24, leaving us with -4. So that's our expected value. What's our variance of W? So variance of 4U minus 3V. So now the constants get squared. For example, here, what's 16? So what's 4 squared, which is 16, variance of U. And what's -3 squared? 9 plus 9, variance V. These are all in your formula sheet if you guys are very confused. So yeah, we've got those. And so 16, variance of U is what? Is 1 plus 9. What's the variance of V? 1. So it's just 16 plus 9, which is 25. Now, the standard deviation of W is just the square root of that 25, which is 5. So, okay, that's good. Now, this is easy. So now we just want to find the probability of W greater than 5. It's going to be equal to the probability that using your standard normal distribution, it's going to be greater than 5 minus your mean, which in this case we got was -4, so it'll be -4, divided by the standard deviation, which is 5 we got, which will give us Z greater than 9/5, which is 1.8 if I'm not mistaken. So Z is greater than 1.8. So choose E as your answer for that one. Question 19. A confidence interval is to be used to estimate the population mean mu based on the sample mean. Okay, to decrease the width of the confidence interval by 75%, the sample size must be multiplied by a factor of what? Okay, now the width of a, so first let's look at the confidence interval actually. So confidence interval is the mean minus your Z S over root N and your X this plus Z S over root N. Your width is this over here. That's your width. This over here. Well, it's actually with the Z, but Z is just like a constant, so forget about it. It's just S over root N. That is your width. So S over root N. And we want this width to be decreased by 0.75. So 0.75. Now, this is a mistake that many students will make. They will multiply by 0.5 thinking that it's actually decreased by 0.75. But what you've just done here is you've decreased it by 25%. Remember, think of it like this. If you have $100 and you multiply by 0.75, 0.5%, you get 75%. So you get 75 of them. So it means you've decreased it by that 20. You've actually decreased it by 25%. But here we want to decrease it by 75%. So we want to decrease it by 0.25. Now it's actually decreased by that 75%. So for this case, because we're decreasing, we're actually going to multiply by 0.25. And which is 1/4. It's a quarter. So 1/4. So imagine 1/4 gets multiplied by 1/4, which is just S over 4 root N. And we want to find the sample size must be multiplied by what? So bringing that 4 into the square root, it's just going to be 16N. So it needs to be multiplied by 16. So D is your answer for that one. Question 20. If a one-sided statistical test at 5% level of it would be concluded that what? Okay, so we are given the null hypothesis and the p-value, and we want to know which one would be rejected. This is all you need to know. If your p-value is less or equal to your level of significance, which is 0.05 in this case, we reject the null hypothesis. If the p-value is greater than 0.05, we accept the null hypothesis. That's all you're going to need to know for this kind of question. So this is the only basic thing that you need to know. So for this kind of question, okay, let's look at this. P-value is actually less than 0.05 in this case. So we reject the null hypothesis, but here it says we should not reject it. So that's wrong. B says it's actually, the p-value is greater than 0.05, meaning that we accept the null hypothesis, but here it says that we should reject it. So that's also wrong. The next one says, if p is less than, so it's 0.03, which is less than the 0. So we reject the null hypothesis. So it says the null hypothesis should be rejected. Yes, this one's true. Yeah, and that's it. I hope you guys learned something from this. Please make sure to like and subscribe to this channel. Please share it with your friends. And thank you so much. I hope you guys have a great day and take care of yourselves. Bye bye.